A single sentence inside a document your AI agent reads. Okay, that's it. That's the whole attack. No malware, no phishing link, no password. Just text that turns your AI agent's own conversation into a shell on your machine. Microsoft calls this class of bug prompts become shells. Let's separate what's confirmed from what's still just a warning. Semantic Kernel is Microsoft's own open source framework for building AI agents, over 27,000 stars on GitHub, used to wire large language models into real tools, file systems, code execution, databases, company plugins. In May 2026, Microsoft's own security team disclosed two vulnerabilities in their own framework that let a prompt, not a person, a piece of text, escalate all the way to running code on the host machine. Think of it as two sides of a line, an attacker outside your environment crafting one document, and your AI agent inside your environment, trusting that document by default. Everything that follows is what happens when that line gets crossed. Here's what actually happened in two parts. Part 1, Semantic Kernel's vector store. The component that retrieves relevant documents for the agent builds a filter using Python's eval function, and it stuffs in a value the AI model controls, unsanitized. That's CVE 22262260 CVSS 928. An attacker who controls one retrieved document, one line in a file the agent reads, can break out of that filter string and run arbitrary code inside the agent process. Researchers said it plainly, one retrieved document is enough to launch a process on the host running the agent. Part 2, Semantic Kernel's code execution plugin runs untrusted code inside an isolated sandbox. That part's fine. But a file download function meant for internal use got accidentally exposed as a tool the AI model itself could call, with no path validation. That's CVE 2226 225592 CVSS 99, even higher than part 1. The two-step version, get the sandbox to write a malicious file, then use that expose function to write it straight to the host machine, for example, into the Windows startup folder, so it runs automatically the next time someone logs in. Put the code for both bugs side by side and the pattern's obvious, one string handed straight to eval, one file path handed straight to a file write, no check on either one. Both bugs share the same root cause, treating AI model generated input as safe when it isn't. Is this being exploited right now? Confirm, both CVEs were responsibly disclosed to Microsoft's own Security Response Center before going public, and patches shipped the same day, Python SDK 139.4, .NET SDK 1.0. Here's the official record for both, straight from the National Vulnerability Database. Microsoft's write-up gives detection guidance for anomalous child processes and unexpected file writes to startup folders, which is normally a sign defenders are watching for exploitation, not confirming it's already happened. Unconfirmed whether anyone's actually used this in the wild. No malware samples, no command and control domains, no named campaigns tied to these specific CVEs as of this writing. But researchers tracking the wider sandbox escape landscape have gone on record predicting at least one real production AI agent compromise tied to this bug class by the end of this year. This is a the fuse is lit story, not at the buildings on fire story, at least not yet. Is any of this technically new? Yes. Eval injection is one of the oldest bug classes in the book. Sandbox escapes aren't new either. Even prompt injection itself has been a known category for a couple of years now. What's new is the wiring. These old bug classes now sit directly behind an AI model's own output, and a huge number of teams building on these frameworks still treat the model said so as safe input, rather than as attacker-controlled input from an untrusted source. That assumption is the actual new vulnerability, one root cause, two different roles, the same compromise on the other side. This isn't just a semantic kernel problem. Underneath a lot of AI agent tooling sits a JavaScript sandboxing library called VM2, and in 2026 alone, 13 separate VM2 sandbox escape vulnerabilities were disclosed, CVSS scores clustered between 9 and 10, covering everything from prototype pollution tricks to WebAssembly-based escapes. Same underlying shape, code that's supposed to stay contained, finds a way out to the host's file system, network, and process controls. Add that to what we already covered with ServiceNow's AI platform sandbox escape, SharePoint's deserialization RCE, and Langflow's IDOT to RCE chain, and the pattern's pretty hard to miss. Old attack surface, your servers. New attack surface, whatever runs your AI agents. Why does this keep slipping through? Two SDKs, two separate patch cycles, Python and .NET, shipped on the same day but as different version bumps, which is exactly the kind of fragmentation that leaves partial deployments exposed. And underneath that, most application security tooling was built to check whether user input is sanitized before hitting a database or a shell. It wasn't built to ask whether a language model's output is sanitized before hitting a database or a shell. That's a gap in the tooling itself, not just a gap in any one team's patching discipline. So, what actually fixes this? 1. Upgrade Semantic Kernel Python to 1.39.4 or later, .NET to 1.7.1.0 later, today if you're running either. 2. Treat every tool parameter an AI model can influence as attacker-controlled input full stop. That means path validation, allow lists, and no raw eval anywhere near model control strings. 3. Watch for the tells, unexpected child processes spawned by agent code, and file writes landing in autorun locations like the startup folder. The throughline Microsoft's own team put it best. Any tool parameter the model can influence must be treated as attacker-controlled input, not as a nice to have. As the actual security boundary, quick recap. A single retrieved document can trigger code execution in Microsoft's own agent framework. Confirmed and patched, not confirmed exploited yet. It sits inside a much bigger sandbox escape wave, hitting the tools AI agents run inside. And the fix isn't really a patch, it's a mindset. The model's output is not a trusted source. I'll keep tracking this thread. AI agent frameworks are turning into this year's biggest new attack surface, and this won't be the last one. Subscribe if you want the next one when it lands.